Yes, we can see your slide.
Okay, thank you so much. My name is Seleshi Getahun. I am from the Netherlands here in Technical University of Delft. My topic is modeling climate change impacts on the water, energy, and food nexus. Basically, this is kind of a wider circle of group of people, but I mentioned some of the directly involved people here, authors from Utrecht University, Wageningen, and Delft as well. And I have to, up front, I have to tell that there is really separate result on energy, food, and water resources thus far. I'm not going to present really the very concrete data or result on this, but I will discuss on the approach, and I hope to encourage motivate discussion for going forward. Now, the idea is to see synergies and trade-off between these three important global issues, which in three sectors particularly, that is the land or food, and water and energy particularly the renewable energy part that we give emphasis. Well, I think you can already see the next slide. Anyway, we are focusing on demand and supply. So how much supply do we have on these three global, let's say, resources? And how much demand do we have on this? And where are the risks or let's say the potential hotspots in this global and regional data? And our exploration, of course, because these are issues currently in the land, water, energy, climate impact nexus, both issues debated, but the global and regional data or result is not really available. And our recent study published in Nature Energy on part of these three nexus, which is energy, shows that not much is actually known about the impact of climate change in this regional and global aspects of renewable energy. So why do we want to study this? Well, first, separately, there's a water resources study and more or less on the land and biomass and related land-related studies. And then on energy, as we say, we review that particularly on global and regional scale, not much is known in terms of impact of climate change. So we want to bring this big data, available climate models and impact models on hydrology, land and water resources to produce some sort of knowledge in terms of impact in the future. So the overviews indicate little quantitative studies at regional and global studies. That's the findings. More or less, as you can see, probably not. Some regions don't really have any studies conducted in terms of regional assessments as well. This is the energy part. And the idea is to quantify what supply we have in terms of these three, and what demand we have in terms of, again, the three. Also, in terms of locations, where is the energy, where is food produced or potentially highly available, and where is it demanded? And to drive meaning out of this. So producing index at a global scale, that is. And the approach we are following is from the intersectoral impact model intercomparison project, which is a revolving project of global partners and institutes. They produce data and standard protocols to follow in terms of the global circulation models, in terms of RCPs, SSPs, and other data sources actually. There's tons of data there that we like to drive meaning out of based on these three. So the standard in this ECMIP data is in terms of spatial resolution, it's 0.5 degree, approximately around 50 kilometers by 50 kilometers. And then we use impact models, for example, for hydrology, energy, and agriculture. Again, these impact models are produced global and regional, well-defined, let's say, protocols are available to simulate any global or regional model, and they dump the results in this ECMIP storage. And then out of that one, we like to intercompare every model that is producing impact, climate impact, based on combinations of climate scenarios, of course. So on the energy part thus far, we have produced, well, okay, sorry, one moment. Let me get back a bit. So just to explain, on the water supply side, energy supply side, food supply side, and then on the demand side, again, the three, water demand, energy demand, food demand. At the end of the day, what we are looking to produce from this is a runoff, for example, from the hydrological models, which is available already. These are the data we are actually using. And there is water demand and surplus water, for example, potential yield, food demand, energy potential, energy demand, surplus energy, and so on. Now, we want to calculate actually and at the end the risk on energy and food and water and hotspots that are globally or regionally identifiable. The importance of this is that there could be energy somewhere, a very high availability of energy, but it may not translate to usability just because of several other limitations, including distance. And then, of course, when you balance it globally or regionally, there may not be visible demand and supply, let's say, variations. But when you see localities, there will be high energy somewhere, availability, and then less demand or less accessibility. Whereas on other places, there could be surplus. So we want to show the spatial risks and, let's say, hotspots on these areas. This is our wish to see the next century from the early, let's say, from 2010 to 2100, in terms of these are the two climate scenarios, but we want to produce 4 of them. So this is just what we like to produce results for. Where we are now, actually, we have, as I said, reviewed climate status, climate impact status on energy on a global scale. On water resources, it's much of this is covered and data is available already. And on the supply and renewable energy, we have a paper that is accepted in Nature Climate Change coming soon. So we have all the data that is, let's say, that can push us to produce the earlier table in terms of Nexus. So we use a multimodal analysis on energy supply, water resources, and land, food models. The WOFOS model, for example, here is modified. And then we apply integrated assessment models to produce a kind of indication for where there is high demand for these nexuses between energy, water, and food. So unfortunately, our overall data production on results is still delayed behind the schedule. but I just want to present that there is this initiative and then effort and encourage discussions and questions that we can cover further. What is interesting here is that the three separately, the food, energy, and water by themselves, of course, could be abundant. Let's say there would be several potential for renewable energy on wind, solar, hydropower, or bioenergy, which is our focus areas. I hope you will read further on the papers I indicated. But there is demand on the other end that is just next door, let's say next country, next region, that is starved for these supplies. And the cost of this connecting these two is actually integrating the cost of these two is where we focus and where we want to drive what it means, what the supply means. Is it economically, technically usable or not? So on the other side, also for water resources, there could be water, abundant water somewhere if we calculate just by itself, but what does it mean when we use it for agriculture, irrigation? What does it mean when we use it for energy, for example, in terms of this aspect? Some make a good synergy, others are actually in a very trade-off basis. And we like to explore this on a global scale and regional scale, which is, as far as we see, less covered. That was the progress we are. Hopefully we will produce something soon. Thank you so much.
Thank you, Seleshi. It's time to have one or two questions. No one? Well, you have a very interesting presentation and project combining a lot of data.
Sorry, can you hear
yes.
me?
Yes.
Yeah,
yes,
just
go ahead.
What kind of socioeconomic indicators or variables are you going to include? How to model it?
Yes, on the socioeconomic aspects, for the three, the energy and water and food, different aspects will come. But overall, we are using the socioeconomic pathway, the SSP standard, where they, just like climate scenarios, they have scenarios for the future population in terms of number of population, growth rate of population, what each will demand in terms of energy, in terms of food, and in terms of land for several services. So there are already data available produced by global initiatives in EASA, for example. We like to follow this socioeconomic SSP scenarios, just like the climate RCP scenarios. And this is our basis for analysis.
Okay, thanks.
But are you using the 5 SSPs available, or are you selecting some of them?
We are, in our earlier analysis for energy, we follow only 2, SSP2 and SSP5 for our own, let's say, averaging, and let's see the average and the likely, let's say, harmonized kind of social scenario. And we use one where there is a high competition globally in terms of economics and so on. But overall, there is really no limitation on how much we can produce. It's all about presentation, and we plug in the scenarios into the data. We are first interested to produce SSP2 and SSP5. As I said, a very likely average kind of growth where there is some kind of collaboration between countries. And the other is a stiff competition for resources. So we like to see those ones. On the climate aspect as well, we are actually focusing on, for now, as you saw it, on SSP 2.6 and 6.0, but the other two scenarios can be easily applicable. So on the results, I would say we'll probably decide at the end of the day, but so far we are working on the two.
Okay. And in terms of energy, for instance, are you going to consider specifically solar energy?
Exactly. So we are focusing on renewable energy overall. So this is an analysis, as you can see on the top probably. There is hydro, solar, wind, bioenergy, thermal, cooling. These are the demand and cost sides. So we are focusing on this all renewable energy parts, the hydrology, the hydropower, solar, wind, bioenergy, and thermoelectric energy. So these are the five aspects of the energy, renewable energy that we are looking for. And we have already produced, of course, a supply for all of this in the next paper, that is upcoming paper that I mentioned.
Okay. We still have a few minutes for more questions. When did you start this project?
The project started, my own focus was 2 years ago with Utrecht University. Now currently I'm a postdoctoral researcher here. Probably I didn't introduce that one in TU Delft. But the ECME project is an ongoing one that is really loosely collaborated, and that has been going for since 2013. My project, particularly the part which uses the ECME data, started 2 years ago.
And so what do you see as the most challenging step in the following months for this project in terms of integrating the data? And
yeah, that's one of, I think that's a good question. At a regional and global data level, I mean, more local and micro level, there is a lot of data on quantified impacts of climate change. But at the regional and global scale, it's only a kind of scientific or policy interest, and then not so much quantified. It's more on a governance level. So quantifying that one into, let's say, this is kind of energy starved area or food starved area or water starved or water excess area will not be easy to say like the separate models are showing. For example, the threshold is difficult to say what is at risk, where can energy travel from one small location to another, or is there a barrier for that? What are those barriers to say that it is, let's say, starved or at risk, or it is of excess in terms of this. So quantifying those ones at the regional and global level is a bit of a challenge in terms of threshold setting, I would say.